Hello there, everyone. Welcome to this weekly presentation of Morrison Planetarium's Tour of the Universe, live and direct from the California Academy of Sciences in San Francisco. I'm Bing Kwok, Assistant Director of Morrison Planetarium. I'm here in San Francisco, but I don't know where you are. I know where one person is. I see our old friend Kate logging in from the UK, and Christian, I think he's in San Francisco. Let us know where you're watching from. We'd love to know how far we're reaching out. And occasionally we have viewers tuning in from different parts of the world, and that's fun to see. As always, if you have any questions, feel free to drop them in the comments, and we'll try to respond or maybe give you some leads as to where you might be able to find the answers. My producer, Hayden, is going to keep an eye out for those. And our vehicle through this, for this trip through the visible universe is the astronomy visualization program OpenSpace, which is supported by NASA and is available as a free download from OpenSpaceProject.com. Now, if you like what you see on your screen during this next half hour or so, you can install this very same program on your own computer at home and fly through the universe and go wherever you want. The download link will list the hardware requirements for optimum performance. Again, that's OpenSpaceProject.com. And we also have a link to a survey where you can tell us what you think of this software, and the developers can use that feedback to help improve the program. So with that, let's take off. We're going to start off from a point that's already in outer space, about 240 miles above the surface of the Earth. We're at the International Space Station, high overhead, orbiting our planet once every 90 minutes or so. This is currently the farthest that humans travel into space, but it's about 4 times higher than the official boundary of outer space. That is around 100 kilometers, roughly 62 miles or so. And that was set because there's no hard and fast limit. There's no sign up there that says open outer space begins here. Scientists calculated that up this high, more than 100 kilometers above the surface of the Earth, the atmosphere is so thin that air control surfaces like wings, rudders, tail flaps, and all those sorts of things don't work. And you need to maneuver around using rockets. So above 100 kilometers or 62 miles, and that's where most of the aeronautical community says that's where outer space begins. And we're 4 times higher than that limit. But we're going to travel even higher than that, because we're going to travel out as far as humans have traveled, period, and even farther than that. So we'll leave the International Space Station behind, which you can occasionally see passing overhead. There are places where you can log in. NASA has one website called spotthestation.com. There are other really nice websites that have information about how you can find space station predictions for your location. One is heavensabove.com. Another one is jamesdarpinian.com. And those are really great sources of information for finding out when the space station will be seen from your location. Right now, we're going to travel to the farthest that humans have ever traveled from the Earth, and that's about 1,000 times farther away than the International Space Station. We're going to our own satellite, the Moon. Now, the Moon is 250,000 miles distant, about 240,000 miles. It's a huge ball of rock about 2,000 miles across, and as we pass over it, we can see that it's covered with thousands and thousands of craters, which are the result of the impacts by comets and asteroids during the Moon's history. And if we travel in close, you can see there are craters on top of craters on top of craters. You can't count them all. There are just too many. And some of these craters are so old. Look at this one right here, which is very old, but it was filled in with material that was bubbled up from underground that filled it in like a big bowl right there. So this is an older crater inside this one. Many impact craters have this central peak at the very center. So that's one really interesting feature that you can use to tell newer craters from younger craters. Here's an old flat-floored crater right here, which has a really interesting set of smaller craters inside it right there. So that you see a lot of interesting things on the surface of the Moon. Now, some of the more notable craters on the Moon's surface are about 50, 60 miles across. notably a few on the near side of the moon facing the Earth, craters such as Copernicus or Tycho or a few others like that. So those are some of the larger, more notable craters that were formed by these impacts, but we can see quite a number of others. If we travel over here to this area of this large round region here, which is half in shadow. Let me turn on a little more light on the surface of the moon so that we can see the entire surface lit up. This large round area here is actually a huge impact feature. It's called Mare Imbrium, or the Sea of Rains, and it's a lot bigger than the other craters you see here. This was blasted out by a huge impact billions of years ago, and it filled in with the lava that bubbled up from underneath. Right on the edge here is a beautiful mountain range called the Lunar Apennines. Wonderful features on the surface of our satellite. When I was a kid, I had my own telescope and stared at the moon through the eyepiece. I could look at the moon for hours into the evening. So this is a fascinating object. But we're going to travel farther away from the moon now. In the next few years, hopefully, the Artemis program, NASA is going to be sending people back to the moon, hopefully to stay. That's what they say. But we're going to travel even farther out than that now. And if we travel far enough, we encounter distances that are so great that it's hard to measure them in terms of miles, which is what we usually use here on Earth. But if we measure the distance from the Earth to the moon, it's about 240,000 miles. But astronomers encounter distances in the universe that are so huge, they begin to use another measuring stick, which is based on the speed of light. And that measuring stick is the terminology used is light seconds, light minutes, light hours, or even light years. If we turn on the orbits of the moon here, let's see, there's the moon's orbit, there's the circle that our satellite makes around the Earth, 250,000 miles in radius, or about 500,000 miles in diameter right there. Astronomers say that this distance from the Earth to the moon is 1.5 light seconds, because it took the radio signals from the Apollo astronauts about 1.5 seconds to reach Earth, to go back and forth. Light takes 1.5 seconds to get from the Earth to the moon. So that's the term that astronomers use, 1.5 light seconds to cross that 240,000 miles. As we travel farther out into space, we'll encounter other greater distances to the other planets, to our star, the sun, and to other stars, which will be measured in hours. And if we turn on the trails of the planets, we'll see them showing where the planets orbit our star, the sun, which is at the bottom, just coming into view here. Nearest to the sun is the planet Mercury, about 36 million miles away from our star. And then next comes the planet Venus, second from the sun, which is 64 million miles from the sun. And then Earth, where we are, 93 million miles away. It takes the light of the sun 8.5 minutes to cross that 93 million miles. And so astronomers say that Earth and the sun are about 8.5 light minutes across. So that's one way to measure the great distances that we see in outer space. And beyond Earth is the red planet Mars, the fourth planet, which is about 1.5 times the distance of Earth from the sun. And after we pass Mars, these 4 inner planets are called the terrestrial planets. They're like the Earth. They're small, relatively speaking, and rocky. And then after that, after Mars, comes a gap that's filled with chunks of rock and rubble and material left over from the formation of the solar system. This is called the main asteroid belt. And there are hundreds of thousands of asteroids that we see here. And we're beginning to explore the astronauts. We've sent some spacecraft through the asteroid belt, and they have passed by some of them and given us a good look at what these objects look like up close. And after the asteroid belt come the giant planets. First is the biggest planet of all, the giant planet Mercury. And there's recently been some news about Jupiter, rather, is the biggest planet. And there's recently been some news about Jupiter that just came out yesterday, I think. And that is astronomers have announced the confirmation of about a dozen new moons around Jupiter. So that gives Jupiter the largest number of moons in the entire solar system. How many moons do you think Jupiter has? We used to learn in school it had maybe 12, maybe 9, maybe 16. Then recently they went up to dozens and dozens. The last count was up to about 80 or so. Yesterday's addition of 12 new moons around Jupiter raises the total to 92. Can you imagine the sight of 92 moons in the sky? That's what you would see if you were out in Jupiter space. Then after Jupiter comes the ringed planet Saturn, and then the next two planets, the ice giant planets, Uranus and Neptune. Jupiter, being the biggest planet, is about 11 times as wide as Earth. Saturn, about 9.5, 10 times. Uranus and Neptune each are roughly 4 times the diameter of Earth. So they're not quite as big as our planet, but they're still a lot bigger. And those are the major planets of our solar system that we are now being taught about. There used to be a planet that we counted out there when I was in school. This was the planet Pluto, which a lot of people still argue should be considered a planet, but actually Pluto is now what's classified as a dwarf planet, which means it's not quite big enough to bully other bits of debris out of its orbit like the other major planets do. It is big enough to orbit the sun. It's big enough to pull itself into a round shape. But the one criterion that astronomers say it doesn't meet is it doesn't have enough gravity to bully bits of debris out of its orbit like the other planets have done. It hasn't cleaned its path through the solar system. So they're calling Pluto a dwarf planet instead of a major planet. But there are lots of other dwarf planets in our solar system as well. In fact, a lot of dwarf planets exist in what is called the Kuiper belt, also known as the zone of trans-Neptunian objects. And there are lots of things out here, mostly short period comets, but other large bodies that could, on closer inspection, might be reclassified into dwarf planets the way Pluto has been, along with a few other things in this area. So time will tell as astronomers get a better look at the objects out here in the Kuiper belt. We may or may not be adding to the number of dwarf planets in our solar system, joining Pluto and the 4 others that are known so far. But look at all this stuff out here. There's a lot of junk out here in our solar system. And as we travel even farther and farther out, let's look at one more thing. We'll look at the farthest spacecraft that have traveled from Earth. Now, these are our most distant physical emissaries. These spacecraft are Pioneer 10, going off by itself in this direction, and then Pioneer 11 going in the other direction, the opposite direction. The longest path belongs to the Voyager 1 spacecraft down here to the lower left. And then there's Voyager 2, which was launched at about the same time as Voyager 1. But then after it passed Neptune, it took a turn down off the plane of the solar system. And then the 5th path there, the shortest one, belongs to the New Horizons spacecraft, which passed Pluto just a few years ago and is now exploring that trans-Neptunian zone where the Kuiper belt is located. And we'll see what else is out there as well. So we're gradually learning more and more about the objects in our solar system, thanks to telescopes and spacecraft which have been sent out into the beyond. Now we're going to have a look even farther out, beyond where our spacecraft have traveled. Our most distant spacecraft is still only about 17 billion miles away, which is only about as far as light can travel in less than a day, about 22 hours. So we haven't really traveled very far into the universe. Although we say we've left the solar system, we haven't gotten anywhere near the nearest stars. Now, those nearest stars are light years away compared to the sun, which is only 8.5 light minutes. If the sun were to suddenly turn off, all of a sudden we wouldn't know it for 8.5 minutes, because that's how long its last light would take to reach us here on Earth. But some of these stars out here are light years away. The nearest one to us is Alpha Centauri, 4 light years away, 4 1/3 light years away. So its light would take 4 years to reach us. And out here in this area, we actually encounter the most distant artifact of humanity. and that is our radio signals, which have traveled out at the speed of light for the past roughly 90 to 100 years or so, traveling as fast as 186,000 miles per second. But it's still taken those radio signals about 100 years to get out this far. And you can see that these are our earliest radio transmissions sent out that got through Earth's atmosphere. There are some stars that are located within this radiosphere. So, if there are civilizations on planets orbiting any of the stars inside the radiosphere, they might be aware of us. They may have received our radio signals. But if there are civilizations outside the radiosphere, they don't know about us yet because our radio signals haven't gotten there. So that's the amazing thing about light and radio waves and how fast things travel and how big the universe is. As Douglas Adams wrote, space is big, unbelievably big. And as we travel out farther and farther into space, we'll encounter things that are not just light years away, but tens or hundreds of light years from us, billions of light years in some cases. So there's our radiosphere, which I will leave on so that we know where we are located. We're always centered on Earth in this view in open space. And so as we travel farther and farther out, we see where we are in the Milky Way galaxy. Now, about 100 years ago, astronomers didn't believe that there were other galaxies in the universe. They thought the Milky Way was the only galaxy in the entire universe. But Edwin Hubble showed them there are other galaxies far outside our own, and these galaxies are all getting farther and farther apart. So not only did he show us that the universe was bigger than we thought, it's getting even bigger still. And you can see how flat the Milky Way galaxy is. It's a typical barred spiral galaxy, very flat but very broad. It's about 100,000 light years in diameter, which means that a beam of light would take 100,000 years to cross from one edge of the galaxy all the way across to the other. We on Earth, at the center of our radiosphere here, are nowhere near the center of the Milky Way. We're about two-thirds of the way out along the edge of one of those spiral arms. And there are lots of other galaxies that we can see nearby. The Milky Way belongs to a small cluster of about 80 galaxies or so called the Local Group. And the next nearest large spiral galaxy, like the Milky Way, is one called the Andromeda Galaxy, which you can just barely see with the unaided eye. It's easier with a pair of binoculars. But if you go out these evenings and look toward the west, in the right spot, you might be able to see a dim, fuzzy smudge of light through a pair of binoculars. That's the Andromeda Galaxy, the nearest large galaxy to the Milky Way, but the most distant object that you can see with the naked eye, if your eyes are good enough. If you can see that object, you're seeing across 2.5 million light years. So the light of the stars in the Andromeda Galaxy took 2.5 million years to reach our eyes here on Earth. If you want to know what that galaxy looks like right now, you have to wait for the light that's leaving it right now to reach us, and that'll take 2.5 million years. Now, since we're outside the Milky Way, looking at our local group from the outside, all those spots that you see in the background are not stars like they were when we were inside the galaxy. All those colored spots are actually other galaxies. And the colors indicate the particular surveys that were used to map them out. And this shows that galaxies come in huge clusters, large groups, superclusters as they're called, that can contain thousands of galaxies. And as we travel even farther out, we'll see that the clustering of galaxies shows us an unusual shape to the universe. As we travel farther and farther out, the large-scale structure of the universe starts to come into view. The distribution of galaxies starts to look rather unusual. And if we turn in just the right way and look at our universe model in the right from the right angle, it starts to look rather strange. Here we go. We're looking at our current model of the universe, which is based on all the surveys that have been taken so far, showing us where the galaxies are with respect to one another, where the clusters of galaxies are. And you can see that our model of the universe looks rather like a giant butterfly with two big wings or cones or fans that stretch off in opposite directions. That empty space in the middle, is that really empty space? No, it's not. It's actually just a part of the universe that we haven't mapped very well yet. It shows us that our model is incomplete because we still have to map a number of galaxies that are in this area, which is blocked from our view because of the dust and gas within the Milky Way itself. Remember the flat shape of the Milky Way that we saw earlier, just as we exited our galaxy? Well, when we look along the plane of our galaxy, we're looking in this direction toward this gap between those two big fans in our map of the universe. And so the dust and gas in the Milky Way itself is blocking our view and preventing us from seeing a lot of the galaxies that we know are here. But eventually, as our technology and techniques get better, we'll be able to map out, look through that gas and dust, and see the galaxies that are out here and fill out our map a lot better. So it'll be more uniform in every direction. Traveling even farther out, we come to some of the most distant objects that have been observed from Earth. Farther and farther out, in the neighborhood of roughly 10 billion light years, are objects called the quasars, which are very energetic objects considering how far away they are. And astronomers think that to be so bright from so far away, they must be tremendously energetic and powerful. And nowadays, astronomers think that quasars or quasi-stellar radio sources are actually the cores of newborn galaxies powered by supermassive black holes. We've learned a little bit more about supermassive black holes in recent years, looking at the supermassive black holes in our own Milky Way and in another nearby galaxy called M87. But these are still mysterious objects that we think are at the centers of all large galaxies. And the farthest out we've been able to see anything at all is to a very, very strange form of radiation, a strange form of light that permeates the entire universe and comes from every direction, something that astronomers call the cosmic microwave background. That's the mottled pattern that you see in the background there behind our model of the universe. And this is a temperature map of the very, very early universe. So this is the first energy, the first light that was able to travel from one place to another. Remember, I said about 100 years ago, Edwin Hubble discovered that the universe is getting bigger. The galaxies are moving farther and farther apart. Astronomers calculated backwards to try to figure out when that expansion began, and they calculated that it began around 13.8 billion years ago. And at that time, the universe was very dense, very hot, very opaque, and light couldn't even travel through it because it was so opaque and so dense. But then, for some reason, the universe suddenly became very transparent, very dense, very cool, very rarefied, and light could begin to travel from one place to another. And about 300,000 years or so after that moment of expansion began, this light, which we see as the cosmic microwave background, was able to permeate the universe. And that's what we see when we scan the universe out this far. And this is the farthest that we've been able to observe. This is the limit of the observable universe. And that being the case, the only place for us to go now is back in toward where we came from. And it may occur to you that as we look at our model of the universe, it seems that we put ourselves at the very center of the universe. Is that really where we are? No, it's not. This is just the result of the fact that we're the ones who made the map. This is the result of our perspective, us looking around us at the universe surrounding us. If there were someone in some other point in the universe making a map of their universe as they saw it, their perspective would put them at the center of it. So we're not really at the center of the universe. We really don't think we are. We don't know even if the universe has a center. But as you travel even farther and farther in, back toward our Milky Way galaxy, back toward that radiosphere at the edge of one of the spiral arms. We've seen thousands and thousands of galaxies, each one consisting of hundreds of billions of stars. And you might wonder whether or not those stars are actually orbited by other planets, worlds like our own that constitute solar systems orbiting other stars. Well, as a matter of fact, astronomers have discovered other planets orbiting distant stars. These are called exoplanets or extrasolar planets for short. And these circles that you see mark the locations of stars that are known to be orbited by at least one planet. Since about 1994, astronomers have discovered more than 5,000 extrasolar worlds. And for a long time, one observatory called the Kepler spacecraft looked in one direction for about 4 years. And that's why there's this big column of extrasolar planets stretching off toward the upper right. There are lots and lots of exoplanets in that direction. But again, as we develop better and better techniques and better technologies, we'll be able to look in all directions with the same degree of precision. And our map of exoplanets will fill out more uniformly, just as we expect our map of the galaxies to fill out more uniformly as well. Are any of the 5,000 planets that we know about so far, are any of them like the Earth itself? We don't know. We're pretty sure that a lot of them aren't, because they orbit the wrong kind of star, or they're the wrong kind of planet. They appear to be very large, like Jupiter, and very close to their stars. So we think they're too hot for life to exist on their surfaces. But you need a lot of things in order for a planet to be able to support life. It's got to be the right kind of planet, made of the right kind of stuff. It's got to have the right combination of elements and minerals that will provide the nutrients for life to survive. And so there are lots and lots of conditions that need to be fulfilled in order for a planet to be able to support life. Only one planet does satisfy all those conditions as far as we know, and that's one that orbits the third from our star, the sun, the one that we call Earth, the one that we call home. This is the one planet that has life on its surface, which exists in a very delicate balance with its environment. So that means it's a place that we need to take really good care of in order for that life to continue to survive and for the planet to continue to be able to support the life upon its surface. And with that, after traveling through the galaxies and traveling between the stars and showing you other places in our universe, welcome back home to our own planet Earth. Thank you very much for joining us on our tour of the universe. This is the last time we'll be doing a private showing for you in an enclosed room or lab or studio here at the Academy. Next week, the tour of the universe returns to the Planetarium Dome and will be performed in front of a live audience. So you can share that experience with several hundred other people as we take you on a tour of our cosmos. We want to thank you all very much for joining us on the tour. We appreciate your support, and we invite you to join us online every Wednesday at this time for Morrison Planetarium's live tour of the universe. Thank you very much. Have a good evening.